Hello student, let us see circular motion, uh, the kinematics part of circular motion, and after seeing the kinematics part we'll come to dynamics part of the circular motion. Now in kinematics, whenever an object is moving on circular path, we will observe if the radius of the circular path is not changing, so but the position of the object as it moves on circle, its position vector is changing. So once the position vector is changing, we can find out what is displacement, what is distance covered by the object on circular track, and then we'll find out average velocity, other kinematics changing velocity vector. Once we know the change in velocity vector, once the object is moving on circular path, if we decide what is the change in velocity vector, then we can find out what is acceleration vector of the object also. So let us see the different kinematics parameter like displacement, velocity and acceleration with time when an object is moving on circular track. Now whenever we'll see, suppose on a circular track, let us take on a circular path, the object is at t equals to 0, the object is at A. Let us take this is center, and at t0, let us say the object is at A. Object is at A and it starts moving on this circular track, right? Now I can say the radius of the circular track is R. This R is the radius of the circular track. Now at t equals to 0, the object starts moving on this circular path. Now as it moves, we'll observe when it is at this point, its position vector, if position vector is changing, you will observe the magnitude of position vector is not changing, that is equal to radius of the circle, but the position vector is changing since the direction of the object is changing on the circular track. Now at let us take at delta t seconds, after delta t seconds, let us take after delta t seconds, that is t, the object is at B. The object is at B. Now we can find out, once the object at t equals to 0 at A, I can say its position vector can be represented by, let us take, the position vector is represented by R1 vector, right? R1 vector is position vector when the object starts moving at t equals to 0, and when it reaches at B, let us say the position vector is, R2 vector. Is it clear? Now let us take after t seconds, it makes theta angle on the circle. When it moves from A to B, it makes theta radian at the center, right? Now we can find out when we join this part, when we join A to B, I can find out its displacement vector is given by this part, that is, let us take delta R vector represents the displacement vector when it moves from A to B. Now I can write down the displacement vector first. The first kinematic parameter is displacement vector, and I can say this displacement vector can be written as delta R vector, that is nothing but R2 vector minus R1 vector. Is it clear? This is the displacement vector. Or I can say the magnitude of displacement vector can be written as simply by delta R is magnitude. I can take the magnitude of this vector, right? Is it clear? Now I can find out the displacement vector delta R displacement vector can be written as root under, we can write down R1 square plus R2 square minus 2 r1 r2 cos of theta angle, where theta is angle between when the particle moves from A to B, theta is angle between the two position vector. So this, now we will observe the magnitude of position vector r1, magnitude of position vector r2, they are equal to radius of the circular path. So I can write down this value as equals to, this value can be written as 2 times r square, 2 times r square and 1 minus cos of theta. This can be written. Now I can find out the displacement vector delta r is nothing but it can be written as 2r square and 1 minus cos theta is 2 sine square theta by 2 and then its square root, and this can be written as the displacement vector can be given as delta r equals to 2r sine theta by 2. Is it clear? This is the magnitude of displacement vector when the object is moving from A to B. Now you will observe when for different value of theta, let us take, I can say when the particle makes 90 degrees, suppose it moves and it is normal to the original position, initial position vector. If I say theta is 90 degree, I can find out the magnitude of displacement vector delta r is equal to 2r sine of 45, and this can be written as 1 by root 2, so root 2r is the magnitude of displacement vector. I can also find out in second position, let us take the theta is 180 degree. In that situation, you will observe the magnitude of position vector or displacement vector. The magnitude of displacement vector is 2r sine 90 degree, and then this can be written as 2r. Right. Now you will observe in third situation, you will observe when theta is 360 degree, when it makes complete circle, then I can say it is 2r sine 180 degree, and this is 0. So in three different situations, you will observe what is magnitude of the displacement vector. Now, what is distance? Suppose the object moves from A to B. I can find out what is distance covered by the object. The second one, I can say distance covered by the object is, distance covered by object is nothing but this is arc AB, arc length, arc AB is the distance covered, is it? And theta is equal to L by R, so I can say the arc length L is nothing but it is R times theta. R times theta is S. Right, this is the distance covered by the object. Now the distance covered by the, now I can find out the ratio of these two. Suppose I want to find out what is the ratio of distance covered by displacement on the circular track. I can write down this value as R theta divided by 2r sine of theta by 2. This r gets cancelled, so I can say this is nothing but 2 by 2 sine theta by 2. Suppose one example, when theta is equals to 180 degree, I can find out the value of S by delta r, that is delta r, that can be written as how much? You can see theta 2 pi radian, 180 means pi radian, pi by 2 times sine of 90 degree. So this can be written as it is pi by 2. The ratio is S equals to S by R equals theta is pi radian. So I can write down theta is pi and then 2 sine theta by 2. 2 sine 90 degree, sine 90 is 1. So pi by 2, the ratio is pi by 2. Is it clear? Now simply you can also see when the object moves from A and it reaches at this place exactly at 180 degree, this arc becomes half of the perimeter, pi r, and then this becomes 2r. So pi r by 2r is nothing but pi by 2. So that way also we can find out what is ratio distance by displacement, distance covered by the object and the displacement. Now I can find out the average velocity of the object. Now the average magnitude of average velocity can be written as the magnitude of displacement vector delta r by delta t. Now I can say delta r is nothing but it is equals to 2r sine theta by 2, and delta t is t seconds, so I can write down this as t. Is it? This is the magnitude of average velocity. Is it? Magnitude of average velocity can be written as 2r sine theta by 2 by t. Now let us find out what is relation between how can I find out the linear speed? Now the linear speed v can be written as linear speed of the object can be written as v as equal to arc AB, this is the distance covered, arc AB divided by time interval is t, so I can, theta is L by r, so I can say r theta by t, and r theta by t is nothing but r omega. So I can say the linear speed is v equals to omega times r. Is it clear? The linear speed of the object on the circular path is equal to omega r. Omega is angular velocity of the object. Angular velocity of the object is nothing but 2 pi by time interval. So that is another part. Now let us find out, once we know the linear speed and relation between angular speed and linear speed is v equals to omega, let us find out what is the change in velocity vector when the object is moving on the circular track. Once you know the change in velocity vector, you can find out what is acceleration vector. So let us find out what is change in velocity vector while the object is moving on the circular track. Now for that we'll draw the velocity diagram for the object. So let us see what is velocity diagram. How can we find out the acceleration vector from the velocity diagram? So let us see the change in velocity. Now at the two instant, at t equals to 0, we'll draw the initial velocity vector as v1, and at t equals to after time interval delta t, let us take after t seconds, the object is at b, there the velocity vector is we can find out as v2 vector. So I can find out the change in velocity vector easily. So let us see how to do that part. To find out the change in velocity vector, let us take change in velocity vector. Change in velocity how can we find? Suppose the object at t equals to 0, this is center of the circular path. At t equals to 0, let us take the velocity vector is represented by velocity vector v1. This represents the velocity vector v1 at t equals to 0. Is it clear? At t equals to 0, the particle velocity is represented by v1 vector. Now after t seconds, After t seconds, let us say the velocity vector is represented by v2 vector. Is it clear? After t seconds. Right, and let us take this angle is theta. Now we know whenever the at two instant, whatever the angle between the radius vector, the same angle exists between the tangents drawn at the 2 points. So this angle will be nothing but theta. Is it? Now to find out change in velocity vector, I can say delta v vector can be written as velocity vector 2 minus velocity vector 1. Now the object is moving on this with uniform linear speed. So in uniform circular motion, I can say when the object is moving with uniform speed, uniform circular motion, I can say the linear speed is represented by, let us take v. Right. So I can say the magnitude of these two velocity at the two instant is same, and that is nothing but equal to linear speed of the object moving on the circular path. So in uniform circular motion, this is true, that at every instant the magnitude of velocity vector is constant, that is nothing but the linear speed of the object. Now I can find out the magnitude of this change in velocity vector as, can be written as root under v1 square plus v2 square minus 2 v1 v2. Angle between v1 v2 is nothing but cos theta. Is it? Whatever angle exists between the two radius at the two instant, the same angle is between the two tangents drawn at those 2 points. Now since v1 v2 are equals, so I can say this value is nothing but it is 2v square minus 2v square cos of theta. So I can say this value is nothing but root under 2v square, and 1 minus cos theta is nothing but 2 sin square theta by 2. To 2 sin square theta by 2. I can say this value is 2v sin of theta divided by 2 is the change in velocity vector. Is it clear? The change in velocity vector is 2v sin theta by 2. Now let us say when the object makes an angle of 90 degree, what is change in velocity vector? How can I write down this value? I can say this value is 2v sin theta by 2 sin 45 1 by root 2. So I can say it is nothing but root 2 times the linear speed. Now when theta makes, let us take at 180 degree, the change in velocity vector can be written as 2v sin of 90 degree, and this is 2v. And let us take after 360 degree the same. Now this is the change in velocity vector is 2v sin theta by 2. Now I can find out the acceleration vector. The acceleration vector can be written as, let us take the acceleration vector can be written as change in velocity vector by time interval delta t, and this is nothing but 2v sin of theta by 2 divided by t. Is it clear? Now I can say when theta is small, suppose t tends to 0 for very short interval of time, or when t tends to 0, let us find out instant acceleration. So I can say sin theta by 2 can be written as theta by 2 only. So I can say the acceleration vector is nothing but 2v theta by 2 by t, and this can be written as v times theta by t is omega, and this can be written as v square by r. Also it can be written as omega square r, or v omega is acceleration. Is it clear? When for very small interval of time, when the object is moving with constant speed, I can find out what is acceleration, that is v square vr, and that is also equals to omega square. Now let us find out what is direction of this instant acceleration whenever we are finding out the acceleration vector, what is its direction. Now to decide the direction, you will observe, if you draw the if you just see the velocity diagram, I can say this was representing velocity vector v1, is it? And then this is representing velocity vector 2, and the angle between these two is theta, right? Now I have to find out what is v2 vector minus v1 vector, so I take minus v1 vector and I will complete the parallelogram, and once the parallelogram is complete, I can say this is the direction of change in velocity vector delta v. Now you will observe this angle phi is nothing but it is 180 minus theta, and since both are constant, I mean both the magnitude of both the velocity vector is same, so equal vectors, the resultant divides the equal vector, and I can say the angle, this is phi, and the angle which it makes with initial velocity vector can be written as this much, right? So I can say this value of phi by 2 is nothing but it is 90 degree minus theta by 2, and this I can say as alpha. Let us take this is alpha. Now when theta is small, I can say alpha is 90 degree, or I can say the change in velocity vector is nothing but it is perpendicular to velocity vector 1. It means what? It means if we take the change in velocity vector, this is exactly normal to the velocity vector. This is the direction of the change in velocity vector, I can say, and now this is the direction of acceleration also. Since this when theta is very small, I can say the direction of the acceleration vector is towards the center, and this acceleration, since it is towards the center, I can say this is nothing but this is a centripetal acceleration, because it is always pointing towards the center. I can say this is radial acceleration, is also it is called radial, and this value is nothing but v square by r, omega square r, or v omega. All three you can write down for the centripetal acceleration. Now since the acceleration is towards the center, so that is why this is known as centripetal acceleration or radial acceleration. Now once it is accelerated, when the object is moving with constant speed on the circular path, we find out everywhere it is accelerated towards the center. Now this is the direction of acceleration, towards the center. Whenever it is moving with constant speed, this is the direction of a vector. So it is always pointing towards the center. Whenever the object is moving on circular path, the acceleration is always towards the center, and obviously once the acceleration is towards the center, we have to find out some force which is acting on the object and which accelerates the object towards the center. That force is nothing but known as centripetal force. And centripetal force is mass time the centripetal acceleration. So I can say the centripetal force is mv square by r, or m omega square. That centripetal force is also acting towards the center. Now once the object is moving on the circular path, there is need of a central force or centripetal force on the object, so that the object is having acceleration v square v r. So in next class we'll see the dynamics part of the centripetal force, what different places we need centripetal force and how can we find out this value. So this is the kinematics, and the dynamics part we'll cover in next class. Thank you.